Alright, on to question 33. And it says, parallelogram ABCD with dimensions in inches is shown in the diagram below. What is the area of the parallelogram in square inches? Alright, so I just skipped ahead so you didn't have to watch me draw this. Okay, so it wants to know what is the area of the parallelogram ABCD. So this entire area. It gives us that this length right here, the bottom of this triangle, as you can see, which is part of the parallelogram. This is supposed to be a straight line. This part is 3, this orange part. This pink part right here is 6. And there are two ways we can actually solve this problem. I'll do both of them. One way will, and it gives us that this is equal to 4. Well, the area of a parallelogram is equal to the base times the height. And the height is the straight line that drops down from the top of the base to the bottom of the base. And the base is this whole length right here, the whole bottom. So the height would be 4, not the 5, it would just be the 4. So base times height would be 3 plus 6, or the base would be, base is equal to 3 plus 6, the height is equal to 4, and from that we can see that the area is equal to 9 times 4, which equals 36. Or say if you didn't know the area of a parallelogram, then you could have just broken the parallelogram down into two triangles and a rectangle. So it would have looked something like this. This is our parallelogram. Pretend that's all straight. Let me make this a little bit straighter. These are all straight lines. This is a right angle. This is a right angle. And this is length 4, 3, 6, 5. Well, in a parallelogram, we know that the two bases are going to have the same length. So this up here will also be, or this will be 6, and this will be 3. And the two sides will have the same length. So this will be 5. And then it'll make this side 4. Because if we have a triangle, it'll be 3, 4, 5. Pythagorean triple. You can use the Pythagorean theorem to solve for this 4, but it gave it to us. So now we can just solve for the area of this rectangle, or this triangle right in here. We can solve for this area right in there. We can solve for this triangle's area right in here, and we can solve for this square, or this rectangle's area, and then just add them all together, and that'll give us the total area. So the area of a triangle is base times height, so we'd have 3 times 4 divided by, or times 1/2 for the area of a triangle. The area of a triangle, so that would give us 6. Then we have 2 of these triangles. We have this one right here and this one over here. So we do the same thing, but that'll just give us 6 again. 3 times 5, or 3 times 4 divided by 2. So plus another 6. And then we have this rectangle, and the area of a rectangle is equal to the base times the height, which is 6 times 4, equals 24. So we have 24 plus 6 plus 6, and that will give us 36. So answers are the same, and you could have used either way to solve this problem, and a lot of AC2 problems are like that. You can approach them from a multitude of ways. It's just whatever one you prefer. Alright, I'll see you in the next video.